Hi, myself Karthikeyan D from Welltech iTech Engineering College. This is about my final year project, automatic pixel level segmentation for cardiac biventricle using Spatio Temporal contest learning under the guidance of Mr. M. Saktivel. This is Titan IT Solution. They are the one they will help me for the completion of this project. Abstract. The aim of this project is to develop an improved region-based active method for accurate segmentation of left ventricle from the cardiac magnetic resonance images. Accurate segmentation of cardiac biventricle from magnetic resonance images have the great significance to analyze and evaluate the function of cardiac vascular system. We have used a neural network concept for training the images and testing the images with the help of weight estimating classifier. Introduction. In the digital world, the vascular disease is the leading cause of death, claiming around 17.17 million lives a year globally. Cardiovascular disease causes a great deal of mortality and morbidity globally, which is one of the most common reasons for death worldwide still now. So we have developed an automatic segmentation of cardiac biventricle from MR images. It's an essential step for the quantity analysis of the left ventricle and the right ventricle. It's a typically necessary for diagnosis and treatment of cardiovascular diseases. In the existing system, the resolution of feature map and spatial information after 3 max pool layer need to be solved before our model training. So two corresponding sampling layer has been restored image resolution. To compensate the loss of resolution caused by the pooling layer, the cardiac deep ID introduced skip connection between its encoder and decoder. Skipping connections help the decoder path to recover fine-grained information from the encoded path. So the high resolution information is passed by means of standard skip connection between the encoder and the decoder. Problem statement. In the process of segmentation, the decoder cannot recover much information, spatial information lost when restoring the spatial resolution. The resolution of the feature maps and spatial information after 3 max pool layers need to be solved. Literature survey. In the year 2018, author named Yang Zhang and Yomi Ong, they created a survey based on automatic segmentation of LV and RV right ventricle in the cardiac MRI. The merits of the system is a fully convolutional neural network to efficiency segment. They proposed a fully convolutional network architecture combines skip connection and learn better features. Demerits. It is very difficult to make the distance of the static slice, although the regions belong to the right ventricle look similar in the first and second rows. Same like in other author named Fabin Lins Paul F. Giger in the year 2018, he proposed a system named as Automatic Cardiac Disease Assessment on sign, time series segmentation and domain specific feature with the merit of some of the merits of the potential of machine learning methods for accurate, fast and reproducible segmentation and computer assisted diagnosis. For the demerits, the cardiac based instance others than ED and ESWET were not considered in the scores due to unavailable ground truth table labels. In our proposed system, the input images are converted into color images from grayscale to color images. The image features like color, weight, depth, and pixel information to apply before the classifier. The segmentation algorithm is used to order the segment the portion of defected areas. The neural network concept is used for training the image and testing the image with the help of weight estimating classifier. This is the basic block diagram of our project, where input image is converted to grayscale and we have applied a medium filter and we have to extract the feature and segmentation process is carried out, and we have set a model using a neural network and training and testing, and finally the result will be published. This is a basic activity diagram where we are selecting an image and those image is converted to grayscale image and the noise of the image has been reduced and the filter is applied and segmented and classified based on the portions affected in the MR image and the disease name has been announced. This is the ER diagram. The first step where the input image is given by the user, which is converted to grayscale conversion, and the filter has been applied. In the second step, it has been adjusted by using a medium filter and segmentation process is carried out. In the third step, the affected portion is separated by using the neural network concept. Finally, the database has been compared with the trained images and the type of disease has been announced to the user. This is a basic system requires software requirements of MATLAB 2013 is a minimum requirement and the hardware should be an i3 processor with a 8 GB RAM of CPU 3.0 Hz. Modules. It consists of 3 modules, namely pre-processing, segmentation and classification. Pre-processing. If the input images are color images, then we are converted to grayscale from the color images. Then it can be converted to binary conversion. Then media filter is applied in order to remove the noise from the image. Segmentation. Surface, one of the most growing technology which we use in segmentation, quite popular mainly in computer vision application. It should have high accuracy and speed in comparison to other feature discrimination in context of object recognition. The image features like color, weight, and depth and pixel information to be applied before the classifier. So we can help it helps to order the segment the portion of affected areas. The third module is used to establish a neural network concept. Is used for training the image and testing the image with the help of age estimating classifier. This is the output of the model 1 pre-processing where the input image is given as a magnetic resonance image and it's converted into a resize with a proper size and they are converted to grayscale image. After the grayscale we are applying a medium filter. So finally the enhancement image will be replaced in the module 1. In the module 2 the segmentation process is done. Around 100 iteration of threshold is set to the identifying the particular process. So after the iteration, the segmentation part of the defected area is defined by the computer. After that, we are using a pattern recognition neural system to find out the disease which is present in the user input. Finally, the result name is showed to the user. Thank you. Have a nice day.